two random samples of sizes 9 and 7 gave the sum of squares of deviations. Okay. Sum of squares of deviations from their respective means as 175 and
95.
Keep in mind, if this number is sum of the squares of the deviations from means, it is nothing but n into s square. How so? Actual formula, what is the actual formula for, this is shortcut we have done, standard deviation formula. Actually, it is square root of x minus x bar whole square by n. Yes? Clear about this point?
Yes, sir.
I'll write it here roughly. Sigma x minus x bar whole square by n. Taking the under root. That is the standard deviation.
Yes,
Do you remember?
Yes, sir.
If that is yes, what is s square? This root goes. What is there in the numerator? Sigma x minus x bar square. Is it the sum or not?
Yes, sir.
Yes. It is the sum of the squares. Of the deviation. X minus x bar is deviation. So sigma x minus x bar square means what? Sum of the squares of the deviations. And this denominator n, if you take left, what happens? ns square. ns square is equal to sigma x minus x bar square. So what is sigma x minus x bar square? 175. That is the value of ns square for the first sample. I hope you have understood.
Yes, sir.
Right. Next, can they be regarded as drawn from a normal populations with the same variance? When the word mean comes, it is t-test. When the word variance comes, f-test. But here f is given directly. So you can figure out that way also. H naught, common ID, difference is not significant. Difference is significant for H1. Here we have N1 9 and N2 7. This sigma is how much? 175. Means N1 S1 square is 175. Similarly, this one N2 S2 square is 95. So you are ready with the
Variance.
Carefully listen. Variance is sigma cap to square is one variable and the f test value is only this much. So simple.
Yes, sir.
F test is having sigma 1 cap square by sigma 2 cap square. Only you have to see that which is bigger, which is smaller. Since this is bigger than this, I am taking bigger value in a numerator, smaller value. If this comes less, suppose, then it will become sigma 2 cap square by sigma 1 cap square. Then the question comes, what is the sigma 1 cap square? Then it is to be calculated this way, n1 s1 square
by n1
minus 1. So that 175 by 8 is nothing but n1 minus 1, 9.
Yes, sir.
So 9 minus 1, 8. Similarly here, 7 minus
7
1,
minus
6.
1,
6. So what is sigma 1 cap square? 21.875. Sigma 2 cap square is 15.83. So this is bigger. So this should come in numerator. So f is equal to sigma 1 cap square by sigma 2 cap square. That is this value 1.381. Then jump simply. What is that? Calculated value of f is
less than the tabular. Okay,
calculated value
1.381.
of f is 1.381 and tabular value
4.1.
It is better to draw the figure always and show that point here
381.
tabular value 4.15.
4.15.
So you shade this region, rejection area, acceptance region. Okay, like that you write it. That will be very nice. So calculated value is less than tabular value. Therefore,
We accept
we accept the null hypothesis H naught. Hence the difference is
not significant.
And you remember like this. H naught, then not. Okay.
Yes, sir.
H naught, not. H1 significant. The difference is significant. The last one, question number 30. That is, we are at page number 40 of 41. Only one page remaining now. Now find the value of chi-square. Is there anyone to ask now, sir, how should we know the problem is chi-square test? Anyone? No. Chi-square is written, this is chi-square. So by looking at that chi-square, this is nothing but chi-square test. So there are three tests for you. What are the three tests?
T test, F
T test, F test and
chi-square.
chi-square. Chi-square is discussed here.
Yes, sir.
right? And sometimes what happens, instead of like this, okay, observed values and expected values, that is needed. That is, you need to know experimental values and
Observed
observed values. Means theory and practical. Theory values are given like this.
Yes, sir.
Practical values are given like this. Whenever this type of situation is there, that is the link between, relation between theory and practical, then you have to use chi-square test, keep in mind. Now, just a simply given data.
Yes, sir.
Actually, it is written solution here, but solution is starting next line.
Yes, sir.
It is a part of the question. Don't think in solution we are writing that observed values and from where we are writing that may be a question. So actually this is a part of the question. Understood the point? So very nice. Observed values are given and expected values. These observed values are practical values. It is observed. This is theory says some values. Theory. What theory comes in that one, that is chi-square test. Why do you bother? It will be given no chi-square value.
Yes, sir.
Chi-square value given. So it is chi-square test. Observed values, expected values. Null hypothesis, fit is good. That is nothing but difference is if you fit something, a minor difference is there. What do you say? The fit
It is not good.
Good. Difference is not significant. I think you are clear.
Yes, sir.
Okay, very nice, good. Now chi-square formula. Chi-square formula is I is equal to 1 to n sigma OI, that is observed values. OI means O1, O2, O3 like that. This is I value running from 1 to n. So O1, O1, E1 like that. O1 minus E1 whole square by E1. Are you clear about this?
Yes, sir.
How do you remember this one? That's the question.
Observed value?
In the examination, even if you take
Anything?
EI minus OI, however you are squaring
Same
it.
value.
Yes, sir, same value.
Yes or no?
Yes, sir.
So numerator is not an issue. What is the issue?
Denominator.
EI. You may forget and in the examination you are getting doubt. That is EI or OI. EI or OI. So you should have some background to clear that confusion, no?
Yes, sir.
Then you just think like this. If you read ABCD, first E will come. Then O will come. So first what comes? E comes. That E is there here. Is it okay? Good idea to remember?
Yes, sir.
Numerator not an issue.
Yes, sir.
Yes, sir.
Okay, fine, good. Now observed value minus
Expected
values
by
14 was there. Observed
Yes,
value.
yes.
Below that one 17 was there.
Yes.
So when 17 is there, 17 will
17
be.
right. Yes, sir.
Simply that I am substituting this.
Yes, sir.
OI minus EI values. So finally it has come how much?
8.8.
8.80.
Slow.
Calculated value is how much?
8.8.
Calculated value is
8.80.
8.80. Tabular value is
11.07.
calculated value is less than tabular value. Therefore we accept null hypothesis
null
H naught. Where H naught the difference is not
Significant.
here. Actually I have written it in my handwriting somewhere and it has gone and then I did not get time to keep whitener here. Right? So no problem at all.
Yes, sir.
The difference is not significant. Hence fit is
Not good.
fit is good.
Fit is good.
Fit is good. Difference is not significant.
Not
Means not much difference.
Yes.
Difference is not significant. There is a minor difference. So the fit is
Good.
good. If I take a ready-made shirt, if minor difference is there, what do you say? It is good fit. But if it is this much long, then I'll say fit is
Not
good.
Not good. Difference is more.
Yes, sir.
Fit
Yes,
is
sir.
not good. I hope you understood.
Yes,
Yes,
sir.
sir.
So at what level it is significant?
5%.
5% of
Significant.
5% level of
Significance.
significant I should write here, significant. 5% level of
Significant.
significance also is okay, no?
Yes, sir.
Yeah, significance is correct. Okay, 5% level of
Significance.
I'm sorry, I'm taking back my point. It should be significance only, right?
Yes, sir.
Now, at what level?
5%.
So some people will say, okay, this is good. Means at the 5%. At 10% level of significance, that may be different answer for that.
Yes, sir.
So successfully we have finished the revision of all that 30 questions. Because the program started 1.5 hour late, the program is ending 1.5 hour late.
Yeah.
Expectation was 4 o'clock.
Yeah.
It has come up to 5:30.
Sir,
it's
two
okay,
first
sir.
question కూడా frame చేసి చెప్పొచ్చు.
Definitely. Because that if I include that 30 will become 50. Then
Yeah.
people says earlier he said 30, now he is giving 50.
50.
So that is on demand. This is basically completed for pass guarantee.
Yes, sir.
Then you say, sir, already I have taken lunch, I want some sweet.
Yeah.
Then sweet is out of the food. Right?
Yes, sir.
Food is only that lunch without sweet. Now if you want some sweet, we can go next level. Again somebody says sweet is over, I need pan.
Ice
Then
cream.
pan will be there again.
Okay.
About that sweet.
Ice cream.
Yes.
Yes, sir.
Tea also. Yeah, thank you. Thank you for visiting this program. You have successfully participated in this program. I will give some certificate, right? Sure, I will give. Don't think like that.
Yes, sir.